The fundamental theorem of calculus has many applications, one of which is average value of a function f. So if you think about what average means, remember that average is basically the sum over the number of numbers. Okay, you can think about average as the sum over a number of numbers. That's the average. Well, if I'm averaging a function, that's a little bit different. So let's say this is a function. Let's say I'm averaging this function. What I'm essentially averaging is I'm averaging all the y values of this function. So if I think about adding up all the y values, hey, that kind of looks like the area. Interesting. So the average value of f, f of x is going to be, well, to add up values of f, I integrate. And this is going to go between a and b. So I'm going to integrate between a and b the function. Pretty straightforward. But that wasn't the only part of the average value. I also had the number of numbers. Alright, well, in this case, it's kind of weird to think about the number of numbers between a and b. But what I can do is I can take, well, actually, I can do the number of numbers between a and b. That's very simple. It's b minus a. Right? That's how many there are. It's the difference. So the average value of the function f is simply the integral from a to b of f of x dx divided by b minus a. That's pretty good. Sometimes you'll see this written as a fraction out front. It'll be 1 over b minus a integral a to b of f of x dx. And a sort of visual way to think about this would be, let's say here's a function, a to b, and say we have like a really weird loopy function like this. No, that's not a good one. Like that. There's a nice function. Okay, and to imagine the average value, what you can sort of do is say you have water. This is all water, and it's stuck between two walls, but you let the water go, and after a point, it sort of settles out and becomes it becomes flat, basically. This value, this y value, is the average value of f. Because what I'm essentially doing is I'm saying the average value times b minus a, if I multiply b minus a to the other side, the average value times b minus a, which is this length, I get a rectangle, and that rectangle is equal to the original area, which was in blue. And so you can sort of think about the average value being the height of the function if the function was water and then suddenly dropped due to gravity and became one height. I don't know. Maybe that helps. Maybe it doesn't. Anyway. But this is how you find average value, so hooray.